Hello everyone, my name is Pedro Sánchez Medina and today I'll be talking about this article that is called Resveratrol synergizes with low doses of L-DOPA to improve MPTP-induced Parkinson disease mice. It was made by these Chinese authors. What is exactly Parkinson disease? Parkinson disease is a type of movement disorder that can affect common daily activities. Although Parkinson is associated with a wide range of symptoms, the most common ones are the masked facial expression, the forward tilt of trunk, the tremor, and the rigidity, of course. But the main thing I want you guys to understand is that Parkinson disease it's a neurodegenerative process that affects the neurons that produces dopamine, which is a neurotransmitter that it's very important for the normal movement. So, secondly, we're going to talk about the L-DOPA, which is the pre-source of the dopamine. As there's no cure for this disease, there's only treatments that help with the symptoms because we haven't found yet the way to stop the neurodegeneration of these brain cells. So the strategy to treat Parkinson's disease is to increase the dopamine signaling, and dopamine cannot by itself cross the blood-brain barrier. So L-DOPA is the one who is administered to Parkinson's disease patients. So let's keep going and let's talk about the general objective, the overall objective of this article, that it describes how resveratrol synergizes with low doses of L-DOPA to improve MPTP-induced Parkinson's disease mice. So the main idea of the article is to prove how resveratrol, that it's a compound that came from grapes, synergizes with a co-administration of L-DOPA can of course decrease apoptosis, decrease neuroinflammation by increasing the neuron survival and the Th positive neurons to treat the Parkinson's disease symptoms. So the first method we're going to take into account is the immunostaining, which is a method for detecting antigens, taking into account the principle of an antibody bidding to an antigen, which is the specific protein we're looking for. Antibodies normally are attached to markers that generally comes in fluorescent colors that led us in the clinical lab to visualize the distribution and location of the specific cellular components we're looking about. Later in the results we're going to see that. So in the article they use rabbit anti-GFAP and they use rabbit anti-TH antibodies, and as well they use HRP ligated goat anti-rabbit secondary antibodies. So the next method we're going to talk about is the Western blot technique, which in mere words is a technique to identify a specific proteins. So Western blotting is an often used technique to identify and separate proteins based on their molecular weight and type, thus a gel of electrophoresis that give us these little bands. Once we have these bands, we transfer these results to a membrane. That membrane is incubated with labeled antibodies. Once this happens, the unbound antibody is washed off, leaving only the band of antibodies that bind to the protein that we're looking for, the protein of interest. Once this happens, is detected by the developing film, which give us these bands as the result that there's a presence or not of the protein we're looking for. Here we have the results. The first one is the immunostaining, in which we can see we have a control of the normal function of the Th positive neurons, and here we have the one that have Parkinson. We can see there's a lot of difference between this amount of fluorescence and this absence of fluorescence, And here we can see that the ones who were treated with resveratrol and low doses of levodopa had an increase of the TH neurons, showing that there's a dopaminergic neuroprotective effect of the co-administration of these two. We have the Western blot, in which we have the TH protein, and we have the alpha-synuclein protein and the alpha-tubulin. The alpha-tubulin was used as a control, and here's important to take into account that the alpha-synuclein is a protein related to Parkinson's disease, so there's a decrease of the expression of the alpha-synuclein in the ones who were treated with resveratrol and levodopa, and there's an increase of the TH, that it's an indicator of normal neuronal activity of dopaminergic neurons. Here we have one of the most important Western blot and results for me that show us the IL-1B, the BCL2, the BAX, and the ClubCAS-PAS3. As well, they show the alpha-tubulin as a control, and in here you can see that all these proteins are related to apoptosis, and the expression of the BCL2 show us there's an inhibition of the apoptosis, and as well they show us that there's a increase of the neuronal inflammation. And we have this other Western blot in which we have these three proteins, again alpha-tubulin as a control, and they measured AKT and PAKT, and that these two proteins are important. It's known that they are important in the signaling pathway of the neuronal survival. So there's an expression of them in the ones who were treated with resveratrol and levodopa, showing us that there's a neuronal survival promoted by these two compounds. Then in the discussion we have some quotes made by these authors on the right. I'm gonna read them so quick, and then I'm gonna say if they were taken into account in the article or not. So the first one says that since neurons cannot be replaced and apoptosis plays an important role in the degenerative process of Parkinson's disease, inhibiting apoptosis is another effective way to prevent the development of Parkinsonism that was taken into account. Remember these results about the proteins involved in the apoptosis. Then we have this quote that says that P13K-AKT is an important signaling pathway for neuronal growth and survival. Let's take into account these results, the ones I talked to you about, that AKT and the PAKT that are important in the signaling pathway for neuronal survival. And finally, we have that continued use of levodopa for Parkinson's disease comes with considerable side effects. This is true because that's the main reason of why researchers and scientists look for alternative treatments. Finally, we have all the conclusions of what I just said before, so I'm going to skip that. And finally, I'm going to say that molecular biology nowadays has changed the way of understanding, the way of treating many disorders, many pathologies. So for a medicine student nowadays, this is so important to take into account this beautiful subject. Thank you all for watching this video. Hope you enjoy it.